Let's take a moment to understand the anatomy of software. Software is basically composed of binary 2-unit values of 0 and 1 to communicate in a language which only a machine or computer can understand. When these binary units are combined in a structured sequence, also known as an algorithm, with a guide on how to interpret each pattern, they can be used to represent information in a language or expression that makes sense to a human. As you can see here, this is the sequence or pattern of binary zeros and ones that are all combined in a larger pattern or larger sequence to represent more complex information. How is data stored? Data on a system is stored virtually, using basic building blocks of memory known as bits and bytes, which are capable of expression. These special instructions that are communicated to the computer are encoded in units called binary digits or bits, and when many of them are combined together, you get larger units of higher capacities of expression known as bytes. What is a bit? The smallest unit of memory used to store information is known as a binary digit or bit for short. A bit can be used to represent the number 0 or 1, which can also be translated to the logical state of 1 being true or 0 being false virtually. Here are the possible combinations for a binary digit or bit. Think of a 1-bit system as a single storage slot or box that can hold either a value of 0 or 1 inside of it, where there are only a possibility of 2 values that can be stored in each slot. A 2-bit system consists of 2 slots or 2 boxes for storage with the option of 0 and 1 for each box, meaning that it has 4 possible binary combinations listed right here. As you can see here, in a 1-bit system, where you have 0 or 1 as the possible combinations or value, this slot or cell can only hold 0 or 1. In a 2-bit system, where 0 and 1 are the possible binary values, you can hold a 0 or 1 and 2 placeholders, and you can hold any of these possible combinations or values. What is a Boolean? A Boolean is a unit of expression that refers to having a possible value of true or false in computer storage or memory. Boolean is most commonly associated with binary digits or bits because with a Boolean value of 0, it represents false, and a Boolean value of 1 represents true. As you can see here, in this binary slot, for example, if there is data that exists in a slot, then the bit would return a Boolean value of 1. If there is no data in this slot, then the bit would return a Boolean value of 0. Basically, it means that if there's data in here, give me a 1, a true value. If there's no data in here, show me or give me a 0, which is a false value. A byte is a collection of 8 bits that can represent a larger range of expression like numbers, letters, special characters and symbols in an encoding known as ASCII or ASCII. A byte consists of 8 bits in a sequence with 8 placeholders having a value of possibly 0 or 1, meaning it can represent up to 256 possible binary data combinations in characters for more complex expressions and storage. A byte has more expressions. A byte can represent up to 256 encoded characters, including letters and words from the English language, numbers from 0 to 255, with 0 included as the first number, and symbols like the $ and ampersand, using the range of possible binary data combinations. Think of 1 byte as 8 bits combined in one sequence or collection stored in 8 slots or boxes that can either hold a value of 0 or 1 inside with many possible combinations. Here in this diagram, you see that a bit is one slot which can hold either 0 or 1. A byte, however, has 1, 2, 3, 4, 5, 6, 7, 8 slots that can hold a 0 or 1 value of information such as letters, numbers, and special characters. More bytes simply means more memory. As storage and memory needs for computers have evolved over time, increased capacity for higher ranges of expression were necessary to meet the demand. Since a bit can only represent 0 or 1, and a byte can only represent a maximum of up to 256 characters using possible binary data combinations, this is very limited, so a new system combining bytes were created. Here, as you can see, there are more expressions and more combinations of data that were created using larger sequences of bytes. Here we have a bit representing only 0 or 1, true or false. Here we have a byte representing 8 bits of true or false. Here we have something called a kilobyte or kilobyte. And basically, this is 10 times a byte. So basically take a byte here with 8 slots and multiply it by 10. This means that a kilobyte can represent up to 1024 bytes of data. Next, we have megabyte. Megabyte is in the millions due to its keyword being mega. And basically what it means is 1 megabyte is equivalent to 1024 kilobytes. And remember, mega means 1 million. Then we have a larger unit called gigabytes. A gigabyte is 1024 megabytes. That means it's in the 1 billion range of expression. So, as you can see here, a byte to a kilobyte to a megabyte to a gigabyte. Each one represents a larger and larger possible binary data values and expressions, and can store more information and even express more information. Bits, bytes, and beyond. Here you can see a bit is based on a 2-bit or base 2 system. So the base for every bit based on the 2 possible binary values of 0 and 1 is the number 2. It starts with 2 to the power of 0, which is 2, meaning that a bit can only express 0 or 1, 2 possibilities. A byte, however, evolves to 2 to the third power, equating to 8 bits. So a byte, remember, is 8 bits, meaning that it has 8 slots or boxes, and it can hold 1 bit per box. Then you have a kilobyte, which is 128 bytes, 2 to the 10th power, which is a larger range of expression, so basically 10 times this. Then you have a megabyte, which is 2 to the 20th power, 128 kilobytes. So basically, a million of these bytes. Gigabyte, 2 to the 30th, 128 megabytes. Basically, a billion bytes of this sequence. And then finally, the last one is terabyte, which is one of the largest storage capacity units today. Terabyte is 128 gigabytes, which is a trillion bytes or more. Let's take a moment to check your internet speed. As you may know, today we use internet speed such as megabytes per second. This unit is basically calculating how much data can be streamed or how fast your internet is, according to your provider. Megabyte, remember, is million bits per second. So here we're using the bits system and we're in the millions. My internet speed is 50 million bits per second. But for a moment, let's go ahead and check our internet speed. Here, I've come to fast.com. As you can see, it's calculating my megabits per second. And here, as you can see, my internet speed is fast. So it's basically saying that my internet speed is 330 million bits per second. Nowadays, with fiber optic technology, you can see speeds like this that are very, very fast for streaming videos, shows, and so much more, even gaming as well. What's your internet speed?